The next thing we want to talk about is an identity matrix. So an identity matrix has to be a square matrix. In other words, the dimensions have to be equal. So what you have is an example here of a 2 by 2 identity matrix, a 3 by 3, and a 4 by 4. What you'll notice is they all have the ones in the columns, in the diagonal columns, starting from the upper left down to the lower right. All other elements are zeros. And once you get finished creating or finding or creating an identity, that's what you're going to look like. Okay? So the first thing we're going to look at is just multiplying two matrices. So the way we notate inverse on a matrix is this right here. It looks like a to the negative 1 power, but it's really not. It means a matrix A inverse. Okay, so what we're going to do is show that these are inverses. That means if I multiply matrix A times matrix B, I will get the identity matrix. And remember, the identity matrix is going to look like this. Whoops, there's a 1, there's a 0, there's a 0, there's a 1 right there. And we capitalize that with a 1. Now, with the identity matrix, the thing that also has to happen is when the commutative property is used on a matrix, which we know doesn't work all the time, you have to get the identity. So it has to work both ways. So let's start with A times B. I've got 1, 4, 2, and 6. And I'm going to multiply that by negative 3, 2, 1, and negative 1/2. So we already learned how to make products, so we're going to use that same idea. So I have 1 times negative 3 plus 2 times 2. And then I'm going to have 1 times 1 plus 2 times negative 1/2. Then I'll move down here to the 4 times negative 3 plus 6 times 2, and then we'll have 4 times 1 plus 6 times negative 1/2. So I have a negative 3 plus 4 is a 1. I have a negative 12 plus 12 is a 0. I have 1 minus 1 is a 0, and this is 4 minus 3, which is a 1. So A times B is 1, 0, 0, 1, which equals the identity matrix. So now what we need to do is test, and it must work for both. So I'll have negative 3 in order for them to be both inverses. And then I'll have 1, 4, 2, and 6. So I'll have negative 3 times 1 plus 1 times 4. And then I'll have negative 3 times 2 plus 1 times 6. We'll have negative 2 times 1 plus negative 1/2 times 4. We'll have negative 2 times 2 plus negative 1/2 times 6. So this is negative 3 plus 4 is 1. Negative 2 minus 2 is 0. Negative 6 plus 6 is 0. Negative 4 Okay, I've got a problem here. Just a second. Oop, I did it again. I just am a little bit weird with those negatives. This is a plus right here. So let me go back and fix that. The thing that catches me is that I know this is a 7, negative 7, and I know it can't be. Everything else is falling into place. So let's go back and see what this affects. So this is a positive 2 times 1, which is a positive 2, And in fact, I didn't catch it there either. That should have been a -4. My brain told me to make it a 0. Okay, and then that, now that works. And then this right here, now that works. Okay, so don't let your brain trick you. Oh, I know it has to be that. Maybe not. Okay, so this is B times A. This is the only time that commutative property works on matrices is if the matrices are inverses of one another. So still just doing multiplication. Okay, now finding the inverse is a little bit different. What we'll do is we'll take a matrix. I'm going to just rewrite this a little bit. This is matrix A. And then the identity matrix is 1, 0, 0, 1 of this 2 by 2 matrix. What we'll do then is we'll take the first matrix, the A matrix here, and we will draw our little augmented line. You know how we did row operations. We augmented the matrix and we attach on the identity. Then we take row operations on this matrix, and whatever result happens over here will produce the identity. So we're going to focus here. We're going to turn the left side into the identity. It's a little bit tedious, but it does work. Okay, so what we'll do now is we'll take our 2, 1, 4, -1, and these are easy when they're 2 by 2s. So make your augmented matrix. Now we're going to use our row operations and fix that. So if we wanted to do a row swap here, we could, or we could multiply by 1/2. I think I'm just going to go ahead and perform a row swap where I'm going to interchange row 1 and row 2. It's just my option. It's what I want to do. So that's going to be a 1, -1, 0, 1, and then a 2, 4, 1, 0. Just making that change because remember, I'm forcing the identity row here. So now I've got to force this 2 to be a 0, so I'll use the additive inverse of 2, which is -2, and I will multiply that to row 1. I'm going to add it to row 2, and that will give me my new row 2. So row 1 will not change. So I have -2 times 1 is -2, plus 2 is 0. This product is 2, plus 4 is 6. This is 0 plus 1 is 1. -2 plus 0 is -2. Okay, so now remember, we don't do anything over here. We're focused on this left matrix. Now I need to turn that 6 into a 1, so I'll use the multiplicative inverse, or its reciprocal. So I'm going to multiply row 2 by 1/6 to get my new row 2. Row 1 will not change. And that'll be 0, that'll be a 1, that'll be a 6, and that'll be a -2/6, which is a -1/3. So I have my column of 1s here on the left. Now I need to turn that matrix, that row, I need to turn that element to a 0. So it looks like I'm just going to multiply this to by row 2 by -1. I'm going to add it to row 1. So I'm going to multiply -1 to row 2. I'm going to add it to row 1. That'll produce my new row 1. Row 2 does not change. Okay, -1 times 0 is 0, plus 1 is 1. -1 times 1 is -1. Now, do you see my problem? Plus 1 is -2. What I should have done is multiplied by a positive. So me making a mistake shows me how to help you check your work. This should have been a positive. So this is still 0 plus 1 is 1. This now is 1, and a negative 1 is 0. This is 1/6, and 0 is 1/6. This is negative 1/3. 1 times negative 1/3 plus 1. So what we have is 1 and negative 1/3. Okay, so we're going to add those together. Remember, that's just 3/3 minus 1/3, which is 2/3. So once you have your matrix in the left, then this matrix on the right is your inverse. So my inverse is 1/6, 1/6, 2/3, negative 1/3. And when you multiply A times the inverse, you should get the identity matrix back. So let me give you one big old vocabulary word right here. When you have a matrix, no matter what square matrix it is, we call this also reduced row echelon form. So when we do row operations, we're putting this matrix in reduced row echelon form. It's also known as the identity. Okay, just to give you some vocabulary. So what's our answer? Right there. So that's the inverse of a 2 by 2. Let's do the inverse of a 2 by 3. A little more tedious, but this one works out relatively nicely. Okay. Make sure it's lined up on my camera. Here we go. So I've got 1, 4, 0. I've got 0, negative 7, 0, negative 5, 3, and 2. We're going to augment that with the identity matrix. Okay. So the nice thing is that the first element, row 1, column 1, is a 1, so I don't have to work with that one anymore. So I also notice that this element's a 0. Now we want to force this element to be a 0 using row operations. So I'm going to use a negative 4 multiplied to row 2. I'm going to multiply negative 4 to row 1 plus row 2 equals. It's easy to get tongue-tied doing this. So row 1 doesn't change. So this is negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 0 is 0 plus negative 7 is negative 7. Negative 4 times negative 5 is 20 plus 3 is 23. Negative 4, then you go all the way across. Negative 4 times 1 is negative 4 plus 0 is negative 4. Negative 4 times 0 is 0 plus 1 is 1. Negative 4 times 0 is 0 plus 0 is still 0. Row 3 does not change. Okay, so as you're working on the left matrix, when you do the row operations, you have to go all the way across. So now we move over to column 2. Luckily, I have 2 zeros here, and I just need to now, to get my diagonal, turn that into a 1. So I'm going to use the multiplicative inverse, which is just the reciprocal. You definitely want to keep the same sign. So that's going to give me my new row 2. Row 1 doesn't change. Row 3 doesn't change, but row 2 will. So negative 1/7 times 0 is 0. Negative 1/7 times 7 is 1. Negative 1/7 times 23 is negative 23/7. Negative 1/7 times negative 4 is 4/7. Negative 1/7 times 1 is negative 1/7. Times 0 is 0. Okay, so fractions do happen, so you're just going to have to not be alarmed by them. Now I'll move to column 3. Now to get my rows of 1s, I have to start here. I have to turn that 2 into a 1. I'll use the multiplicative inverse or reciprocal and multiply by 2. Excuse me, 1/2. I'm going to multiply 1/2 by row 2 to get my new row 2. Actually, row 3. Okay. Row 1 does not change. And I'm just doing a quick rewrite here, making sure my signs, I keep my signs. Okay, 1/2 times 0 is 0. 1/2 times 0 is 0. 1/2 times 2 is 1. 0, 0, 1/2. Okay. Now I've got to zero out this element and this element. So let's start. I need the additive inverse of 23/7, which is the positive 23/7, and I'll multiply that to row 3 and add it to row 2. I'm going to multiply that to row 3. I'm going to add it to row 2 to get my brand new row 2. This stuff I don't require. This stuff just helps you and helps me know what you're doing. My notation that I like is right here. Okay, so row 3 does not change. So 23/7 times 0 is 0, plus 0 is still 0. This is 0 plus 1 is 1. So notice I'm not changing anything to the left of column 3, which is really a good thing if you do the correct order. And then this is 0. Wait a minute. 23/7 times 1 is 23/7. Minus 23/7 is 0. That's what we were trying to make happen. And then I'll have 23/7 times 0 is 0, plus 4/7 is 4/7. 23/7 times 0 is 0, minus a 7th is a negative a 7th. And then I'm going to have a little scratch work here. I'm going to have 23/7 times 1/2 is 23/14, plus 0 is 23/14. That's not too terrible. Okay. Now, in order to not have to write this matrix again, and maybe to keep myself from having a mistake, I want to go ahead and turn this -5 into a positive, into a 0. So I've got to multiply by its additive inverse and then add there. So I'm going to multiply 5 to row 3, and I'm going to add it to row 1 to get my brand new row 1. So I have 5 times 0 is 0, plus 1 is 1. 5 times 0 is 0, plus 0 is 0. Notice nothing changed here. So I have 1 times 5 is 5, minus 5 is 0. 5 times 0 is 0, plus 1 is 1. 5 times 0 is 0, plus 0 is 0. And then this is 5/2, plus 0 is just 5/2. So notice the left side is in identity form or reduced row echelon form. That means that my identity matrix is 1 4/7 0, 0, -1/7 0, 5/2, 23/14, and 1/2. Okay, so that's a 3x3, a little more tedious than the 2x2. What I want to show you with this one more, and we'll be finished. The nice thing is that if you'll look at the one we just did, everything's the same except the last row. Okay, so we're going to replicate some arithmetic. That should make you feel a little bit better. Okay, maybe we'll get a little used to this with practice. Something special is going to happen here, and we can also do this with a 2x2, but I had it, so I just decided to go ahead and use it, just to get you used to the 3 equation 3 by 3 type matrix. Alrighty, same thing we're going to do here. Multiply by -4, add here. Multiply by -3, add here. Okay, so row 1 does not change. So -4, that's a 0. That's a -7. That's 20, and 3 is 23. -4, 1, and 0. Okay, now I've got -3 and 3 is 0. 0 and -7 is -7. Okay, and then that's going to be -15, +15 and 8 is 23. I've done something here, just a second. 1, 5. Let's clean that up. Okay, I don't think I have either. I think I'm good. This is 15 and 8 is 23. And then this, so just remain calm, it'll clean up here pretty quickly. This is -3 and 0 is -3. This is 0 and 0 is 0. This is 0 and -3 is excuse me, that's going to be a 1. That's 0 plus 1 is 1. Okay, so now I need to multiply by a -1/7. So that's going to be a 0, a 1, a 23/7, that's negative, and this is -4/7, -1/7, and 0. This row doesn't change. We're almost done. Keep calm. This is already a 0. That's good. Now I need to turn that into a 0. So I need to multiply this by a +7 and add to row 3. Row 1 does not change. Multiply, that's 0 and 0. Actually, row 2 doesn't change either, so let's get that one in place. Okay, 0 and 0 is 0. 7 and -7 is 0. Okay, now I want you to look at this closely. This is 7 times -2/3 That's going to get you a -23 plus a 23 is 0. Okay, let's just go ahead and finish the process. Multiply those 7s. Those 7s divide out. So that'll get you a -4, and a -3 is a -7. That is a -1, and 0 is -1, and this is 0 plus 1 is 1. Okay, so we're done here. What you notice is that this element is a 0. It has to be a 1. And I've got this, once I get a row of zeros, there's no way that that can be forced to be a 1. So if this happens, it doesn't matter what row, generally it's on the last. That means that there is no inverse for A, and we call that a singular matrix. The matrix A is singular. It just means it doesn't have an inverse. Just some fancy language. So that is a matrix and its inverse.